Good morning, everyone. Thank you for joining us today for our webinar on designing microservices approach in MS Azure for Monoliths. My name is Rachel. I'm with the marketing team here at Compunnel Digital, and I will be hosting any questions or concerns that you have throughout the webinar. Just a few housekeeping things today as we get started. If you do have questions, please insert them on the questions tab on your GoToWebinar application, and we will answer them at the end. We have two very impressive presenters this morning. You could go to the next slide, please. Our first speaker is Kartik. He is our Senior VP of Digital Transformation here at Compunnel Digital. And Kartik is a cloud strategy expert. He has really extensive experience in architecting, designing viable IT solutions for complex business needs. He has over 3 decades of experience, and he's really helped clients transform their businesses at scale with quality and speed and consistency. He delivers end-to-end enterprise solutions, and he utilizes emerging technologies while drawing upon his deep knowledge of architecture, standards, and technology. So he's really been around long enough to see every iteration of these technologies and has a lot to offer. Vishal is our VP of Application Modernization and Digital Solutions. He also has 20 years in the experience, and he works with CXOs across the globe to innovate and create new revenue channels using digital solutions. He guides clients in creating end-to-end commercialization. He starts from the MVP stage to full-fledged product. As a product engineer, he specializes in utilizing emerging technologies to modernize legacy applications, and he also builds new web and mobile applications from the ground up. So both of these presenters today have a ton of experience working with microservices and transferring, transforming monoliths into microservices. So if you could move to the next slide, please, Vishal. So our webinar agenda for today, we are going to talk about the modernization of monoliths to microservices, business use cases for microservices, the journey guide, the approach for how to convert monoliths to microservices, what that looks like, and then what microservices in Azure Cloud looks like, how that platform is really helpful. Your key takeaways today will be a harmonized way of transitioning from monoliths to microservices. You'll understand how microservices help you meet your business goals, and how to decompose your existing monolithic system to microservices. And this is through a phase-wise approach. And you'll understand how to leverage and implement microservices in Azure Cloud to achieve the maximum results. So again, if you are just now joining us, questions will be at the end. Please use the GoToWebinar portal to enter your questions, and we will address them once Vishal and Kartik have wrapped up. And without further ado, I will turn this over to you, Vishal.
Hi, Karthik. I'm going to be taking the first few slides, and then we'll hand off to Vishal, who is the digital engineering expert on this modernization. So here in this webinar, our focus will be primarily to talk about modernization with respect to designing microservices and deploying them on the Azure cloud. So the key aspect here that we're going to talk about is how to do this in Azure. So as we speak, I'm sure all of you have this challenge that you have faced and are continuing to face, which is dealing with large legacy applications, been there for years, decades perhaps, and with a monolithic architecture, and that is any company on this date is struggling to support, struggling to maintain, struggling to keep up, and also all meeting the digital needs of today, where multiple touch points, multiple omni-channel experiences that you have to provide to your customer, and the monolith is standing in the way of doing that. So the goal here is to show you how to use microservices architecture and take away components out of a monolithic application, and then build them out and roll them out in a way that is efficient, scalable, and also able to integrate with your underlying monolith, as well as be able to modernize to the current needs. Vishal, could move to the next slide. Thank you. So one of the three key things that this exercise is going to help achieve is to be able to achieve platform independence. One of the things about microservices is that when you build microservices and in Azure, not only Azure but maybe also other clouds, the the best advantage that you have is it is platform independent. That means you have skills across the organization, and multiple departments having different kinds of skills. The underlying technology is not important. The programming languages can coexist. You can build one microservice in C sharp or a .NET Core, and the other one could be in Java, so whatever. So that is one of the advantages. And the speed to market is the key element of a microservice, where you are able to build components that are reusable, plug it into the other microservices that you need to build, and then be able to get there, implement DevOps perhaps, and all those things are going to help you achieve results faster. And also, by way of going the microservices route, one of the other key things that you can do is you can break components of the application into domains of experience across the organization, different groups that are intimate with their business processes can take up and build their functions much more efficiently, effectively. That's one of the things that microservices that you achieve is the teams can you can leverage the experience across the organization. um, and Vishal, yeah, you can. So the key benefits, most of which I spoke about, is the what it's going to achieve you is a independence, which means different teams can be simultaneously working on things together, enhanced capability in your business because there are multiple teams parallelly achieving results for specific parts of the application that they are modernizing. And then there is the platform independence we already talked about. There are a higher level of fault tolerance can be built in microservices because each of these have a specific set of functions to accomplish, and they are very clearly defined, and they have their own version of truth that they manage. So and also the way it is deployed, I mean, from a technological standpoint, you will be using containers and orchestration that will help you achieve fault tolerance in the cloud, using services like Kubernetes or what have you. And there is also you can do development faster, uh, reduce dependency on specific skills that you need. And of course, there is a heavy level of integration that can be done because of the various services that is offered in platforms like Azure. And naturally, one of the things that goes without saying in the cloud is the availability and scalability, and fault tolerance at the highest possible level. So with that, I'll be handing over to Vishal to go into further details. Please, Vishal.
Yeah, thank you, Karthik, and good morning to everyone. I hope everyone is safe. Uh, Coming back to, we have already talked about microservices is one of the major thing which is coming in the market, and I think it's been very popular nowadays just because it get links with the business and help business to deliver faster stuff. So most of the organizations are nowadays having a monolithic app, which is basically largely a big enterprise apps which are there in the on the floor. And microservices is one of the architecture which has actually been started breaking the application into smaller modules and get them developed separately, and we have already seen the benefits. Now coming back to how that whole journey has to be started. So for example, if you're already having a existing monolithic system which has to be converted into microservices, the one of the thing which most of the organizations start doing is that started like they think they go to the Google, start reading about microservices and start making it, while that is not the exact way of doing it. There are some steps, there is a journey which has to be followed, and that's what we talked about, we are going to talk about here. And in the further slides we will talk more in detail about each and every steps here. So talking about operational readiness is one of the first step which we really have to talk about. Start with the simple and a decoupled edge services. So for example, if you really have to develop a microservices, you can always there is a mechanism, there is a method to figure it out, like within a big monolithic app, which component or which business or which component has to be developed like a microservices. The one of the simplest way to figure it out is that take some edge services like authentication, security, logging. Those are the services which can be taken up and can be done into microservices, because these are the mostly decoupled services which can be created separately. Another thing is that, because when you talk about microservices in terms of doing a programming, whether you use C sharp, Python, Java, whatever, even the cloud architectures, the good part, the one of the thing which Microsoft demands is about the continuous delivery pipelines. So basically talking about how the overall orchestration of the microservices deployment and the overall connectivity will happen between different microservices. For that, the DevOps has to be one of the area which has to be considered, and that is where the operational readiness things comes in. Now one, in the next box we will be going to talk about what are some of the best practices of decomposition of monolithic apps into a microservices. So talking about that, so split sticky capabilities, identify some sticky capabilities and deconstruct into a well-defined domain concepts. So that is one thing which we have to work on, and decouple what is critical and changes frequently. So for example, now talking about, are they both of them linked? So in a system, you have to very well know that what is my area which is good get very frequently changed, or which is an area which is very sensitive in nature. We can always talk about that these are the module which has to be decomposed. So one of the way of finding it out, that okay, yeah, we can always start with a very simple thing by talking about authentication, authorizations things, while if you really have to decompose and ask okay how you want to decompose your monolithic apps and want to take some of the parts to be developed in more microservices, is one of the way to do is that we can start finding out which are the most frequently changed modules which can be developed into microservices. Decouple vertically and release the data early. So move out capabilities vertically, decouple capabilities with this data of to a microservice, exposing a new interface, or modify or redirect consumer to the new APIs. So that is another area. And then talking about we have decouple capabilities, not the code. So there are two ways to extract a service out of an existing system. Either we extract the code or rewrite the whole capability. So one of the area of doing the decomposition is that we can always take the code which has already been written. We can take that code, we don't have to rewrite it. We can always take that code, make it as a microservices, and can actually start using it, or rewrite the whole code and get the same capability which is right now doing it. And then obviously migration to a microservices was one of the areas, like slowly and slowly we can always do that. This is a very, it's going to be a patient process, because most of the organization which have got this monolithic app has been grown organically. It has took years to develop those kind of applications, and it will be take some part. It is not going to be like 2 months or 3 months or 4 months or 6 months kind of a project. It may be bigger projects to convert the complete monolithic app into the microservice. So it has to be done incrementally. So that is where you have to start working. And then there are some methodologies which has to be used, how to make sure that your monolithic app and microservices are working together, how your new users should be directed to your microservices, or based on some of the parameters or protocols or rules, you can always direct the traffic to your monolithic app or to your microservices together till the time it is not completely been developed or transformed into a microservices architecture. So talking about operational readiness. So when we talk about operational readiness, 3 points which comes very clearly for microservices is the infrastructure, because microservices really needs a good amount of infrastructure to be maintained. Reason being because it's require certain level of, they have a protocol which has to be followed. For example, talking about, because you don't know which microservices is going to be having what kind of a traffic to be coming in, whether it's going to be highly used. And obviously when you talk about microservices, they are deployed separately, so they always need in different application domains, they always need a different application boundaries. So for that, you really need to allocate some of the resources like RAM, hard drive, storage capacities, all that has to be done, CPU, all that has to be taken care. So microservices really need a good infrastructure which is required to be get extended to the level where whenever it is required. That is one thing which is more important from an operational readiness. So you need to have a rapid infrastructure provisioning process which needs to be there on place. Talking about pass and disaster recovery, so for example, now your microservices went down and you really need a disaster recovery, or you really need a fallout mechanism, failover mechanism for your microservices. So that's something you have to keep it. Plus, when you are designing the microservices, one of the things which people normally say, okay, I've designed the microservices, but my database is still same, it's a single database instance, I haven't got a failover for that. If you talk about storage, I don't have a storage failover, so those kind of a thing still can fail your microservices. So for that, you really need a platform as a services kind of a concept. So that is one thing which is required for an operational readiness. And then the third point, which is very important for any microservices development, is the DevOps part. Because as you will be developing microservices, you want it to be tested first faster, you want to be get it deployed so that the testing team or a QA team or a your development team can actually see the working. And once it is being done, it can automatically go and it can be launched into the market. So this whole cycle has to be very faster, because it's a very small incremental or a small units which you are going to develop. And one of the beauty of microservices is that it has to be developed faster, it has to be deployed faster, and it has to go to market very faster. So this is an operational readiness which has to be there for microservices. How Azure platform as a service helps in operational readiness. So when we say see, you really need all of these capabilities in your application, in your, while cloud, one of the ways that you can start developing those capabilities from base and making sure that those capabilities can be developed. And I think the aim of any of these organization is not to develop the infrastructure but to develop the business applications. So Azure provides you all those kind of capabilities inbuilt, which is out of the box, and you can use those capabilities to make your microservices. So the core business of creating the microservices for your developer will be achieved very fast if we try to build something on the cloud infrastructure. For example, Kubernetes registries. So you can use Kubernetes as one of the scalable infrastructure, because when microservices are designed, they has to be designed on containers, and containers need to be talked to each other. Earlier it was virtual machines which was being used by the computers, by the applications, but now it is more towards containers. You also have another area which is with another component called Azure Container Registry, which is another area which is also been important when you talk about disaster recovery or scalability. Event driven functions are the important part for any microservices. Reason being, because when you talk from one microservices to another microservices, it has to be loosely coupled, it cannot be tightly coupled. If I am dependent on any other microservices and that microservice is not giving response to me, of course that is not going to solve the purpose, because now I am cannot perform the function which I was supposed to do that. So it has to be loosely coupled. So event driven architecture is one of the area, one of the thing which has to be taken care. And of course that can be easily done by using enterprise service bus inside the inside the Azure. So those are the things which can help you to decouple your microservices. Coming back to the Azure app services, of course, you want something to be fully managed platforms. So Azure app service is a fully managed platform. You don't have to worry about whether my database is working, whether my database is down, how I will scale my database, my storage space is not coming. You can always take those kind of a thing, because you don't know what your microservice is going to be taken. Like you can always estimate it, but for actual thing, you have to be prepared. And of course, for scale up and scale down, you have to make sure that you have a scalable infrastructure on place. So what are the best practices for decomposition of monolithic to microservices? So for example, so one of the methodology which most of the market is using is triple D, which is domain driven design. Now, domain-driven design actually helps you to analyze the domain, and then define the bounded context. For example, if I talk about e-commerce application, payment is one of the area, dispatching is another area, maybe talking about. So these are all the separate components, or maybe doing a different. So it has got its own boundaries, which is already been defined. So you can always create them as a microservices for them. um, so those are the ways people actually start designing the microservices. And of course, one of the thing which we already talked about, that all microservices should be loosely coupled such that it is independent of other domains and business functions, and provide a clear separation of business context. So for example, when I talk about uh, payments are totally in that. Of course, payment is a big module. You can still divide those payment into nano services, or into a microservices can further divide into nano services. That's not a problem, but the intent is that your payment is going to be your one of your microservices, which is going to be connected. So it will be, you look like one unit which will be there, but payment has got its own boundary. It is only going to deal with the payments part. The same way we have got a dispatch kind of a thing, where dispatch is one component and you have a lot of permutation and combination inside the dispatch, but again it have got its own boundary context which has. So your one of the best way to do is that you have to see what is your domain part is, and how you can divide your application into multiple parts so that it can be designed as a microservices. So it is all functional then technology driven. Some people have actually started creating microservices on the basis, okay, I create a common service, something like that. That's not the real microservices concept. The microservices concept is very clear on the business front end, how your workflows has to be there, your business flow, and how you define your business flows, and understand that within this business, what part of my workflow will have a extraordinary load coming in, so that I can increase or decrease the thing. So payments, when at the time of Christmas or Easter, you normally have a lot of these kind of payments coming in. So your payment component has to be designed such a way that it can be scaled up very well. So that is one of the thing. But there are other rules also when you identify microservices components. My migration to microservices, we talked about as a micro, how to migrate it to from a monolithic to microservices. As we talked about that, we're going to design the microservices. Now once you design the microservices or identify the microservices, you start the development of microservices. And we talked about when you have a bigger application which is organically grown in near about like 5 to 10 years, no way we are talking about that it can be converted into a microservices in one go. It has to be taken incremental approach. In that situation, many business leaders have a question that what will happen to my business. Is my business is going to be like, I have to still work on my business, has to go as usual. So what is my strategy towards it? So Microsoft has got a pattern called Strangler pattern helps you. So it puts a proxy in between, where your proxy actually take care of that if the request comes like this, if the request comes for this particular thing, the proxy will take care of that. Okay, I have to send this request to monolithic application. If the request come for this particular module, I have to send it to the microservices module. And of course, the proxy will be taking the ownership of even aggregating the response. So for example, if your application has got coming, if your user is requesting the data which has to become from monolithic, and it has to become from the microservices also, in that situation also, your Strangler pattern is going to help you to collect the overall response, to aggregate the overall response, and take it to the user. Eventually, this is what the cycle we see early stage monolithic applications are bigger, and core microservices are still going to be like less in numbers, because you started with them. Slowly and slowly, your monolithic app will be become smaller and smaller, and your microservices will be become bigger and bigger. And then you can see that there will be more microservices in a monolithic. And at one point of time, all your complete monolithic app will be get converted into microservices. So monolithic will be shrinking over time, and microservices will be increasing gradually as the time progresses. And of course, when you do this incremental, there will be lot of learnings which can be implemented back into it. And one of the good part about microservices, it very well fits into the agile process development even. So if you are an agile development company, adopted agile very well, microservices is a well suited architecture which can be get connected with agile very fast, because agile anyway says that you have to develop something incrementally and in a smaller components, and microservices has actually been take care of those rules very well. So Stangler pattern for handling coexistence of monolithic and microservices. So develop a new microservice with the same functionality as a component in monolithic. Both service will coexist with dispatcher, proxy, tracing request to the component. Microservices will replace the older component. So that is what the Stangler pattern do. And now you don't have to worry about that. Oh, how I have to make a lot of change? No, you don't have to make a lot of change. Stangler pattern, which is a design pattern, take cares a lot about microservices, how the communication between your legacy application and microservices has to be taken care. That is the responsibility of Stangler pattern. Coming to the microservices deployment, of course, a lot of people have got that. Okay, now I have developed the microservices. I really want to I want to make a releases. So there is a concept called canary release, which has been in the market for releasing the or incremental or phase rollouts for microservices. Of course, if you see in the total, what you're trying to do is that you might be doing a phase releases or maybe doing an incremental releases, and canary release is one of the way of releasing the application or microservices in incremental way. This is one of the ways which microservices have adopted, and Azure DevOps actually provides you these kind of stuffs or this release as a default pattern. So how Azure Cloud helps in the implementation of microservices? So quickly build, deploy, scale powerful cloud application without worrying about infrastructure. So for example, high productivity, if you really want from your developers can do an high productivity by putting .NET, Node, Java, Docker, a PHP, Ruby, Python, any of them. Staging and deployment environment can be created. Testing in production can be done. App Gallery Marketplace. Fully managed, yes, it is an auto scale and load balance environment. Highly availability with auto patching, reduce operational cost and backup and recovery. That is another thing. An enterprise grade is global data center footprint, hybrid support, active Azure Active Directory integration. So for example, if you really want to have a secure application or a secure authentication in your application, you can always use Active Directory, which is anyways a built-in integration or an identity management system from Microsoft, and it is a secure and compliance environment which Azure provides you to uh, to develop microservices. This is a high level candidate architecture of microservices. Again, we will talk further about it, how that has been done. So for example, you have got an on-premises application, which is right now sitting here. You have got an API gateway, which is one of the area of microservices. So for example, any of the microservices has to be exposed as an API, which has to be get deployed on a API gateway. Once the API gateway identifies that, okay, you really want to, you are a right user for it, or you are an authenticated user, it will automatically fires an event, which is an event grid. And then within an event grid, you also have a workflow. So for example, while it can be done straight away also, this is one of the candidate architecture. It is not that someone has to build it like that, but it is more loosely coupled and scalable architecture. Reason being because once you put your request to a workflow, your workflow decide that how that request has to be served. Is that request has to be served by 5 microservices together, or it has to be served by 1 microservices? So let the workflow engine decide that how the request has to flow inside it. If the workflow engine decide that I have to get this data from Azure services like Azure functions, or maybe from a SQL database or a Postgres database, so that is also taken care by a workflow engine. Or if micro or a workflow engine talks about that, okay, I really have to get the data from any of the backend services, I should be able to do that. While containers is one of the area we have, if you see this boundary lines, it is basically Kubernetes cluster and it has got containers inside it. And then we also talked about role-based access control, which is basically at Azure Active Directory, which is there. And then this has got a pipeline, which is a deployment pipeline, which is going to be the part of Microsoft, which is basically Azure DevOps, which is going to be taken care all the deployment of microservices. Achieve API management in microservices with Azure? Yeah, definitely. We will talk about API gateway. What is API gateway is supposed to do? We talked about Strangler pattern. Strangler pattern can also be taken care by API gateway in Azure. And as I talked about that, a lot of things are already been built up in Azure. You don't have to recreate or you don't have to reinvent the whole wheel. You have to actually you have got all these component which has been working. So for example, API gateway is one of the places which can actually take care of the Strangler pattern. So gateway routing, it can actually helps you to route the request, whether it has to route to service A or service B, or it has to be get data from both the services. It's an aggregation also. You can aggregate your data, you can aggregate your responses. You can actually have request, you can send it to two different services, even get the data from both the services together into the application gateway and get the response aggregated. You can cache the whole response. You don't have to go back to the databases or microservices again and again. You can cache the thing, and there is a lot of security which can be taken up. And gateway offloading, it helps to offload functionality from individual service to the gateway, particularly cross-cutting concerns like authentication, logging, etc., which is basically very common methods which are very common concerns like cross-cutting concerns, which can be taken care by application API gateway by itself only. Azure workflow, we talked about there is a workflow engine. What should be the workflow? Why the workflow and how workflow is going to work on? So for example, if you really get a event from an API gateway, oh, give me that data. Now, once you get that data from the API gateway, or you get an event from that API gateway, the event has to go to the workflow. And here we are talking about logic apps. Logic apps is anyways it's a Azure by default workflow and orchestration engine, which is already the part of, you don't have to recreate or don't have to find out a workflow engine, you already have it. Now once you get an event from an API that, okay, I really want a data from this particular microservices, or I want this data, you don't specify it, your workflow engine is going to take care of that, how to get the data. So right now it may be getting the data from service bus or it Azure function or DB services, or maybe majorly been talking to other services also, or if it is required to talk to any other services. When I say services, it can be API service, it can be microservices, it can be anything. It will connect to that because Logic Hub has got near about 400 340 connectors right now to get the data from different systems. You just connect with those systems, get the data, aggregate it, and send it back to the API gateway. And that's where it is going to be a good way of doing it. Even you can change the flow of your application later on. So today you are actually going to component A, B, and C, but tomorrow you decide, no, no, we really want to not go to component A, B, and C. We want to go to A and C because B is no more required as a part of our step. Right now, people do that as a hard coding or maybe write that into the code. And for making those small changes, you have to go into the code, make the change, come back again, deploy whole thing, which is not a correct way of designing a microservices architecture. The best way is that you design up with a workflow and just go and change the step. And while you're changing the step, you don't have to change the code. It will be changed in the workflow and the things will automatically start working for you. So that is one of the way of doing it. And some of the things which we talked about is Azure services, for example, loosely coupled architecture. We talked about event driven architecture, how the event has to be raised. So for example, if I am a microservices A and want a data from microservices B, I have two options. I have two choices. One choice is that I go and talk to microservices B and say, okay, give me that data. Other way is that I can raise the event and my microservices B is being enrolled to that event. In that situation, I am not tightly coupled with service microservices B. I'm very loosely coupled. I'm just raising the event, broadcasting it, and whosoever is published or subscribed to that event, because I am a publisher, whosoever is get subscribed to that event, automatically it will grab that event and tell, okay, you really want that data, I can give you that data, and then it's going to be published, and then I am microservices say will get that data back in the similar fashion, the way I have sent the request, the way I will get the response back. So that particular thing, people take like it is not difficult to make it, but yeah, this is going to be a tedious job to do it custom development. But you can easily do it by using service bus as a, because service bus actually helps you to do this kind of event raising architecture. And Azure functions are basically a serverless architecture. So you can actually be in, you don't have to deploy your code and make sure that you provide them in the memory. You can use Azure function. You can put your business logic in Azure functions, which can be easily been connected. So for example, if you connect to a bit, you have a business logic which you don't know how many times it will be running, or it is going to be a whether it will run or not. So you can always design that into Azure function, because it is pay as you go concept. So as your Azure function will be get initiated, you will only going to pay for that amount. Otherwise, you don't have to pay for it. And even if your business logic it's required to run 1,000 copies at one moment, Azure function is going to help you for doing that. So those are the benefits you get when you work with Azure as a platform or a cloud. So this is Azure based CI/CD process, which is basically a DevOps process from our end. Uh, uh, we talked about that DevOps is one of the most required part for microservices architecture, because one of the fastest thing which you really want any application for any business owner is that I give a small change, that change get implemented very fast. And I think development teams do that changes faster most of the time. But the problem happens when they don't test it correctly, and when they don't test it, and even testing a bigger application takes near about like a week or 2 week or 3 weeks, depends on the kind big size of the application. Microservices actually helps you to break that particular strategy, and it says that okay, uh, as you develop and write a line of code, we have a DevOps engine which is sitting behind the scene. As you input or make a change, commit the change, there will be certain level of test cases which will get run automatically, and tells you whether my microservices has been failed. Is it going to pass all the business scenarios, or it has failed on some of the scenarios? If it is failed, it will not get merged into the code. If it is passed, it will get merged into the code, and then slowly and slowly there will be a code promotion happen from dev environment to QA, QA to UA, UA to prod, and all that can be done through DevOps easily. Even one of the best part of DevOps is even to maintain the quality of the code. Even talking about how the code quality has to be maintained, whether your application is having a complete test coverage, what is your code coverage, all that can be taken care by DevOps. Most of the people can actually help most of the people, and I think many of the organizations have actually started developing their own DevOps platforms also, and DevOps environment also. But Azure do have all that as a part of yours. So you can use Azure boards to manage your project management tasks, to manage your sprints, manage your overall manage your sprints, manage your task status, Kanban boards and all that. You can always use Azure. Once you're Azure, you have that, you can manage your releases, task management, developer productivity, all that can from the Azure boards. And then finally, once in coming into the implementation side, MSA, you can always use a lot of these tools which can help you to know the quality of the code to make it faster deliver. And another thing which you can always do from Azure DevOps is also to create the infrastructure from zero, from ground up. So for example, talking about like you really know that okay, my application is such big, if it when it crashed, how I should make my application within 2 hours back in the or how should be I should be back in business within 1 hour, 1.5 hour. So in that situation, DevOps can help you to make that back in to get you back in the business very fast, because now you have a complete build cycle which can help you to do that. And in those build cycle, microservices can also be the part of it. So DevOps is one of the most important part when you start working on microservices. So preferred environment guide, this is our overall learnings, and this is our from our experience that what you really need to be have a preferred environment. So microservices design patterns, talking about Strangler, domain driven design, we talked about most of them. API gateway, we talked about that. Even sidecar is service is something which is a design pattern. Many organizations have adopted sidecar design pattern as microservices pattern too. Reason being because when you talk about logging, authentication, authorization, security, exception handling, you don't want each of your developer to start writing all those again and again. And obviously when they start writing, they write in a different manner even till the time you don't have a very strong protocol to manage that code and the level of quality. So sidecar is one of the pattern which is used by microservices, where you actually develop a sidecar and deploy that with your microservices. And as your microservices lives, the time it will live till the time your microservice is also living. The time your microservices get decomposed, sidecars also get decomposed. So every microservices got its own instance of sidecar services. Saga design pattern we talked about, it's a event driven design pattern. We have to work on that, which is another saga pattern. Cross cutting concern pattern, circuit breaker pattern. Circuit breaker pattern is one of the known pattern, because when you talk about microservices or any of the cloud, the cost to sending any request and response, because there's a lot of small request to and fro comes in. So cost of sending any request is a very what I say is a costly stuff, and you really want to implement circuit breaker pattern to understand how your requests are coming. Even if your microservice is down, you should know that you can tell microservices A, microservices B is down. There's no need to send request to microservices B because it is down right now. So it saves your what I say, it saves a lot of your infrastructure cost. It saves a lot of time of the user, and even it's to give a better customer experience. Coming back to the architecture component, so this is basically we talked about how Azure can help you to do all that which you are planning to develop on house, or maybe trying to develop custom. So authentication services, you can use Azure Active Directory. Workflow and orchestration, you can use Event Grid Logic Apps. Microservices, .NET Core, Azure Functions. Monitoring, you can always use App Insights. Virtualization, Azure Portal is there. And monitoring is one of the most important part in any application. You really want to know when your application is up, down, whether microservices, because if you have 150 microservices, there's no way any of the human being can actually come to know which services is working fine on which is. You really need a automate way to tell you, or the system should tell that, oh, I am this microservice is not working. So App Insight is one of the area which is one of the component. Automation, which we talked about, TDD and BDD. It's a task driven development and behavior driven development. IAC is Helm, which we talked about, is an infrastructure as a code. You can use ARM, Helm, any of these, where you develop the whole infrastructure as a code. You don't have to write, you don't have to create and manually go and create your servers. You can easily create it. You can write the script and the servers get automatically created whenever is required. Project management perspective, we talked about the delivery as an agile methodology, project management, Jira, collaboration teams, OneDrive, and container ecosystem. We talked about Docker, Azure Kubernetes, Azure Pipeline, Azure Boards, Azure Monitor. So those are the things which it's our recommendations when you talk about microservices architecture to be started in your organization on Azure. This is one we recommend. Here I end up my overall presentations, and we are open for questions. Please feel free to have questions from us.
All right. Well, thank you very much, Kartik and Vishal. And thank you all for joining us today. We really appreciate your time. And if you have any questions, please enter them in the GoToWebinar portal. And we do have a few here for you. The first one is, how do you test microservices?
Sorry, Rachel, I haven't got your question. Can you repeat it?
Absolutely. How do you test microservices?
Yeah, let me answer this, and even Karthik can add on it. As per our understanding, microservices has to be developed on a methodology called test-driven development methodology, which is TDD. Once you write the microservices, you also write unit test cases around it. And as you deploy microservices, or as you get into the DevOps engine automatically runs these test cases and helps you to test the microservices that it is working fine. If any of these automated test cases get failed, it tells you that microservices, you have broken something, and you have to, and it will not get passed, and it will not get merged into the main code stream of yours. So that is a way microservices can be tested properly, and there are automation test cases or regression suites can be created for microservices even.
Okay, great. The next question is the use of containers necessary in microservices?
Yeah, use of containers is necessary because in most of the microservices, the intent of developing microservices to get the faster come back faster. Now, if for example, if I take an example where you have an application and you really want a server to be get initiated, so you are already running on one server and you want another server because a scalable option, auto scaling is happening, and you want another server to come up. Now, coming on a server, bringing a new server altogether, configure it, it will take some time, and in that period of time, either your application, which it is going to be crashed, or there will be too much of load and your customer will get not a very or very delayed response. So you really want a very small chunks to be get initiated. Containers helps you to do that. So when you talk about containers, your application microservices get deployed on the containers, and at its scale, uh, your containers get created automatically. As your application ramp down, your containers get killed automatically. So that containers are one of the important part for microservices. It has to be there.
Yeah, okay, great. Let's see, the next question is, while everyone talks about a single source of truth, microservices prescribe their own individual, excuse me, prescribe use of their own individual database. Are these approaches not conflicting with each other?
One of the protocol of microservices is very simple, that it has to have its own own databases, own data. Of course, but then people say single source of a truth. It's but again, it depends on what kind of a data we are talking about. While single source of a truth can be taken care by having a data warehouse or something like that, but when you talk about microservices, you really have to have your own databases, which is going to contain its own data. If you go with the traditional methodology where you have a single source of persistence, which is your single database, then you are not completely microservice architecture, but there's no harm in doing that if your business says that that is the way it has to be done. Because when you talk about multiple databases, of course there is certain level of complexity evolves around it, but that's a true way of developing microservices. So it's not it's breaches, but yeah, there are pros and cons of taking either of the approach.
Okay.
Yeah, and to add to what just Vishal said, the thing is that one of the reasons you write these common cross-cutting concerns into another layer of service is to ensure that those kind of services are there that ensure consistency between the data across the version of the data maintained in the microservices as well as in the central database or data warehouse or whatever they have, where the single source of truth is. So there is consistency that needs to be ensured in your design, so that these conflicts don't happen.
Okay. Thank you both, Kartik and Vishal. The next question is, can we assume that microservices are the best way forward to solve system complexities involved in a monolith?
Uh, there is a different point of view on this, Rachel. Theoretically, microservices architecture is not meant for each and every system. We
Mm-hmm.
have to analyze the system and find out whether microservices is required for that. If it's an application which is of very small nature, not very complex, and of course not very do not have a demand that way, do not have a load of that, so microservices is not going to work on that. And if it's been highly dependent on each other, we have to find out whether we can divide that application into a with the norms of triple D. Then microservices is one of the way to move forward. But yeah, otherwise we have other architectures also, which is service oriented architecture, NTR architecture, where you can do the development in a similar fashion, but not exactly like the way microservices says. But yeah, you can still bring lot many guidelines what microservices says in those architecture too. So it's not completely that everything will be get converted into microservices, but yeah, most of them will be get converted into microservices, as the market is seeing there's a lot of value of converting monolithic apps into microservices.
Great, thank you. Hope that explained the question. And we have one more question here. What kind of steps can help in planning microservices effectively?
Yeah. So, microservice. So we already talked about that, how to create the microservices and how to plan the microservices. So talking about, you really need to have a cross-functional team, which is most important part of it, because microservices is a business idea where business and the technology team has to come together, which is the most important part, because even a technology team can develop it, but business has to tell that what can be divided or what can be divided in a business domain. Second point is very important from the perspective that you have to be an agile methodology adopted organization, because microservices demands that it's going to be in smaller chunks and it has to be faster deployed. That is another thing. And the third important part is that you have to be having certain experience of doing in microservices. If you really don't have, you haven't developed any microservices before and start doing it, of course there will be a learning curve for you. So you need to have a expert or a partner who knows microservices development very well, so that you can effectively deploy or create microservices in your environment. And the fourth part, which is most important, is the DevOps part. You have to have a DevOps in place, so that you can deploy and develop and deploy your microservices faster in the environment, and can promote those microservices into different environments, because it's not possible for you to uh, develop and make changes in the microservice and keep testing it, because testing takes a lot of time, and I think business cannot wait for those kind of timelines. So then that's why they went to microservices. So that is where I see 3 or 4 points which needs to be taken care.
Okay, great. Well, I think that is all of our questions, and I'd like to thank our panelists for being here today. Thank you so much, Kartik and Vishal, and thank you to all of our attendees for spending your morning with us. Just a quick reminder, I will be sending out the PPT and the replay of this webinar as soon as we have the replay available. You can look forward to that on Monday. And we have another upcoming webinar on Thursday, December 3rd. The subject is how CDOs can transform business data into an enterprise asset. So how to really make the most out of your data to make it an effective business tool and to monetize it if you'd like to do that. So that's on Thursday, December 3rd. Keep out an eye for an email invitation on that. And again, thank you so much, everyone, and have a wonderful rest of your day.